Hello everyone. In continuation to our topic pipes and systems, which is a part of a quantitative aptitude, this is the second part. Fourth question. Two pipes A and B together can fill a cistern in 4 hours. Had they been opened separately, then B would have taken 6 hours more than A to fill the cistern. How much time will be taken by A to fill the cistern separately? So let us consider now. Let the time taken by pipe A to fill the tank or to fill the cistern equal to X hours. B would have taken 6 hours more, which means then we can say time taken by pipe B by pipe B should be X plus 6 hours. So this indicates that part filled by, or you can say 1 hour work or part filled by pipe A in 1 hour should be 1 by X. Similarly, part filled by pipe B in 1 hour should be 1 by X plus 6. Okay. Now, together they can fill the cistern in 4 hours, which means in 1 hour part filled by both. In 1 hour, part filled by both A plus B should be equal to 1 by X plus 1 by X plus 6. Since together they can fill it in 4 hours, part filled in 1 hour will be 1 by 4. Now let us solve this. First, let us consider the LCM in the left-hand side as X into X plus 6. Here you have X plus 6 plus X equal to 1 by 4. That means 2X plus 6 divided by X square plus 6X equal to 1 by 4. Now cross multiplying, we have 4 into 2X, 8X, 4 into 6, 24 equal to X square plus 6X. That means X square plus 6X minus 8X minus 24 equal to 0, which is X square minus 2X minus 24 equal to 0. So that we can rewrite it as 6 into 4 is 24, and we will consider minus 6 and plus 4 to factorize this. Split minus 2 as minus 6X plus 4X, because minus 6 into plus 4 is minus 24. We can. So here, first two terms common is X. Next two terms common is 4. So we can rewrite this as X minus 6 times X plus 4 equal to 0, which means X is 6 hours, ignoring -4 as the solution. Okay. So what is the question? How much time will be taken by A to fill the cistern separately? Therefore, A alone will take 6 hours to fill the cistern. So that is the solution for this question. Let us move on to the next one. Fifth question. Two pipes A and B can fill a tank in 20 and 30 minutes respectively. If both pipes are used together, then how long uh, will it take to fill the tank? So since A can take 20 minutes to fill the tank, part filled by A by pipe A in 1 minute will be 1 by 20. Part filled by pipe B in 1 minute will be 1 by 30. So that means together part filled will be how much? Part filled by pipes A and B together in 1 minute will be 1 by 20 plus 1 by 30. LCM of these two is 60. So we have 3, here we have 2. That will be giving us 5 by 60. 5 by 60 is nothing but 1 by 12. Means part filled by pipes A and B together in 1 minute is 1 by 12. This means that it will take 12 minutes to fill in if both pipes A and B together are used. Together are used. That is the solution for this particular. Next question. Sixth one. Two pipes A and B can fill a tank in 15 minutes and 20 minutes respectively. Both the pipes are opened together, but after 4 minutes, pipe A is turned off. What is the total time required to fill in the tank? So from whatever is given, we can say 1 minute work of pipe A equal to 1 by 15. 1 minute work of pipe B equal to 1 by 20. Let pipe A turned off after X minutes. Then we can write as for first 4 minutes, both pipes are open. So 4 times 1 minute work of pipe A, 1 minute work of pipe B, plus X minus 4 times only pipe B is working. So 1 by 20 equal to 1. So this can be rewritten as 4 by 15 plus 4 by 20 plus X by 20 minus 4 by 20 equal to 1. So this and this gets cancelled. Then we will have X by 20, sorry, X by 20 is equal to 1 minus of 4 by 15. That will give us 11 by 15. Which means X will be 11 into 20 by 15. 5 threes are 5 fours are. We get 44 by 3. That if we divide, we get 14 2 by 3 minutes, which is 14 minutes plus 2 by 3 into 60. This and this is in seconds. So we get 14 minutes and 40 seconds. So that means 14 minutes and 40 seconds. So that is the solution for this particular question.